Hello everyone, welcome to SchoolQuizz. Okay, so this side Anjali Singh, and again I'm back with the second video. So in the first video, we discussed about the chapter motion, and the subtopics is like what is the motion, how you can observe motion around your s- environment, as well as the about the distance, as well as the displacement. What type of quantity is the distance as well as the displacement? So motion means a body is moving. Okay, whenever you see about like body is moving, so that is considered as the motion. Okay, so it is moving with the some reference point. Okay, means like the house when the car is moving, so it is moving when we will take a house as a reference point. Okay, means if we'll stand inside the house or nearby the house, so we'll consider that house is stationary and the car is moving. Okay, so after that, distance. So the distance, as I told you, this distance is about the actual length covered by an object. Okay, so the actual length covered by an object is known as distance, and it is a scalar quantity. Okay, and the SI unit of the distance is meter. Clear, everyone? Okay, as I think I explained you with the example also, so please clear this all doubts as well as some queries. Please see the first video so that you will be able to understand the second video, which is going to be start soon. Okay, first we'll revise that some topics. Okay, and about the displacement. Displacement is what? The shortest distance traveled by an object. Okay, how the distance, how the short distance covered by an object, so that is considered as a displacement. It's a vector quantity because it has magnitude as well as the direction, because it is a shortest distance. So definitely to cover a path, to cover a shortest path, an object must be knowing its direction. Then only it recognize which path is the shortest. Okay. Next is it's a vector quantity. Okay. I think I told you now. Its SI unit is also meter. Okay, like that displacement. Okay, students. Now again I'll share the slide so that yes. Okay, I think that I didn't give the information. The first I'll give you, and this, yes, yeah, I told you it's a scalar and it's a vector quantity. Okay, so I told you distance. I think it is given, but I don't know where it is given, but definitely it is given in a book. Distance is greater than as well as equal to displacement. Okay, the quantity of distance will be equal to the displacement. In some cases it is equal to the displacement, and in some cases it is greater than the distance displacement also. Okay, but in case of displacement, you'll see displacement is always less than distance as well as equal to distance. Okay, but it's not greater than distance. Clear? Distance is greater than displacement, but displacement can never be greater than distance. Okay, it will be equal to the distance, but it is not greater than distance. And the most important, okay, tell me, is distance will be zero? Okay, it cannot be zero. Distance cannot be zero. But in case of displacement, it can zero? Yeah, definitely it will be a zero. Okay, I think when you are seeing the video, so many questions are arising in your mind. How it will be zero? When you'll move in a circular path. Okay, I think you saw a small girl which is moving in a circular. They are playing this game when they are catching someone like that. Something childrens are playing. So what will happen? There you can see they are moving in a circular path, and in the circular path, student, I think, okay, I'll explain you. Okay. Yeah, I'll explain you here. Somewhere like, okay, like here. When the object is moving circular, okay. Sorry, it will be a kept, okay, like circular. Okay, when an object moves circular, see, you started from here and you end with there. As I told you, displacement depends on the initial path. This is the initial path and this is also the final path. This is initial path as well as the final path. So it will be 0. Suppose this is A and here it returns to A. So what will happen? A minus A will be 0. So distance cannot be 0, but displacement can be 0. Okay? Okay? Clear? Now, I have to remove it from there. I think distance and displacement is clear to you. Now, uniform and non-uniform motion. Uniform motion is what? You can see in the a body has a uniform motion. When it has a uniform motion, okay, a body has a uniform motion. When it has a uniform motion, it travels equal distance in equal interval of time. So what will be the, no matter how small these interval may be, it doesn't matter. The interval will be large or small, but what is important? Equal distance. You can see there, equal distance. Okay, equal distance in equal interval of time. Okay, what will be equal interval of time? So what will be the important here? When you'll see, yeah, the bestest example is when you'll see the motion of the planet around the earth. So what you are going to observe, the motion is what? It is a uniform motion because every year it's again moving. So like earth revolving around the sun, the planet revolving around the sun, as well as the moon revolving around the earth. So what type of motion it is? It's a uniform motion, means they are covering equal distance in equal interval of time. Clear? So student, this is the graph. Okay, this, you can see, this is the line of uniform motion. Clear, students? This is the line of uniform motion, and it is always be made between the distance time graph. Okay, it always be made from the distance time graph. Clear? Okay, so what will be the important point? Okay, what will be the important point here? Actually, I'm highlighting it. First is equal distance in equal interval of time. Okay, these two lines you have to keep in remember. Equal distance in equal interval of time. And this is the distance time graph. Okay, this is what? This is the distance time graph. And if anyone asks you what distance time graph will give, distance time graph will give uniform motion. Clear, students? And what about the non-uniform? Non-uniform is just opposite. Unequal distance. Here you can see unequal distance in equal interval of time. Means the time will be equal. Okay? The time will be equal. Here it is written in equal interval of time. Okay. Unequal distance. Student, please keep in mind it is unequal distance in equal interval of time. So, like, yeah, when you're traveling in a train, So when you'll see when the station reaches, what will happen? When the station reaches, the speed of the train is slow. Means there it is. And after when the train is moving in an outer area, so the speed is very high. So there unequal distance in equal interval of time. Clear? I think it's clear. And what should be there? Yeah. Okay, first remove it. Then we will go. Here you can see. Yeah, you can see this dropping of a ball. Okay. Again, this dropping of a ball. This dropping of a ball. You can see here it is unequal distance. When you will throw, it moves with a different distance. When it will reach to the earth, it will be of different distance. Okay. So here it is unequal distance in equal interval of time. And this is the graph of non-uniform motion. Student, this is the graph of non-uniform motion. You can see this is a curve graph. Uniform motion graph will be always straight and non-uniform motion will always be curve. Clear? Now, the distance time graph for a body having non-uniform is a curved line. Please keep it in mind. The non-uniform graph will be curved line and for the uniform motion graph will be straight line. Okay? It will be like that. Here it is written. Okay, as I already explained you, it's very easy, dear. It's very easy that in the uniform motion, I know because the graph is very important. When you'll see the graph and sometimes you have to explain the example or something like, so it is very easy to explain with the graph. And even the topic also, when you explain with graph, this is also easy. Now, the next topic is speed, velocity, and acceleration. So first we'll study about the speed. So what is speed? Speed is nothing. It just give you idea about how fast and slow the body is moving. Okay, how fast and slow the body is moving. So this give you exact idea about the speed. Clear? It is like when the bus is moving, okay, and when we are moving. So who is going to calculate? The speed is the quantity which is going to calculate how the bus is going and how we are going. So differentiate between that is the speed. And the formula of speed is, you can see, speed is equals to, yes, speed is equals to distance upon time. What is this? This is the distance. Yeah. Okay. क्या हो जाएगा? The formula is V is equals to S by T. V is the speed, S is the distance traveled, and T is the time. Clear? Okay. Clear? Speed is equals to distance upon time. Clear? Speed is equals to distance upon time. Can anyone suggest from your side what will be the SI unit of speed? Is anyone? Okay, yeah. It's very simple, dear. Like SI unit of speed is meter. SI unit of time is seconds. So the answer is meter per second. Whenever quantity will go from downside to the upside, whenever quantity will go from downside to the upside, there you can see this will be the -1. The power should be converted into minus. I think you read in class 8th exponents and power. So I think everyone knows the SI unit will be meter per second. Clear? SI unit as well as as well as unit is so many like kilometer per hour, kilometer per second. Okay. Okay. There are so many units, but this is the SI unit. And the most important, speed is a which type of quantity? It is a scalar quantity. I think in whenever I'm explaining you about the speed, I didn't talk about the direction. I didn't talk about the direction. So the speed is a scalar quantity. Clear? Speed is a scalar quantity. Okay. I think you can see this is what machine. Okay. This is what machine in a bike. Huh? When you'll see when a child is moving the bike and what he's seeing, I think he's always observing the speed of the bike so that he'll show more smarter, more smarter. Okay, it's a part of example only. Yes, yeah, you can see there are two types of meter. There are two types of meter. One is speedometer, another is odometer. So what speedometer shows? This is speedometer shows the speed of a vehicle. This is speedometer shows the speed of the vehicle, and odometer shows is about the how much the vehicle covered the distance. So the distance traveled by the vehicle is shown by the odometer. Clear? So please keep in mind speedometer, speed, odometer, distance travel. Clear? Okay. Now the average speed. Average speed is like when you'll walk from home to temple, temple to temple to garden, and garden to the return home. So definitely your speed must be different from home to temple, and from temple to garden, and from garden to home. So whatsoever speed, you can see whatsoever distance traveled, like home to temple, then temple to garden, then garden to again home. Total distance and total time. यहाँ की T1, here T2, and here T3. So this will give you average speed. Clear? How much you travel the distance? Okay, and upon the time taken. Clear, everyone? This is your average speed. Your average speed is always also over. You can see this athletes are running, cheetah is moving, as well as spice jet is also moving. This is the example of a different speed acquired by the different organism. Now, uniform speed is what? Uniform speed, again, it is same as uniform motion. Has means equal distance in equal interval of time. Clear? Here it is same, equal distance in equal interval of time. I think it is clear. Here is the one example. So please see the slide. Okay, see the slide and solve this example. Clear? This is the example. It is very easy. You have to convert it. Everyone, I think, know that 1 hour is equals to 60 minute and 1 minute is equals to 60 second. Here you can see in case of meter also, 1 kilometer is equals to 1000 meter. Okay, the relation between kilometer to meter and meter to centimeter. Clear, everyone? Okay, so I think, yeah, our next is, this is also example. So please do it by yourself so that you'll get a more and more practices. Okay. Yeah, this is also example. So you'll pause the video and do the example by your own. I already explained you the formula. Clear? This is the example. You can see this is the example of average speed. This is the example of average speed. Clear? Total distance upon total time. Here the distance is also more than 1. Okay, total time is also more than 1. That is why we have to take the average speed. Clear, everyone? I think this is enough. Okay, these all are example. If you have any doubt in all these examples, so please contact me. Please contact me. I'll always available to help you. Okay, and so please, everyone, please do it and revise it at your home. We'll meet again with the more interesting topic. Okay, thank you. Stay healthy and stay safe.